Welcome! Today, we're going to talk about leveling up your data analysis skills. We're moving past just getting an answer on your screen and into the world of storing it like a real pro. Honestly, this is one of those core skills that really separates the beginners from the seniors.
Okay, so let's just dive right in. You spent hours, maybe even days, cleaning data, running your analysis, and you finally found that golden insight. Now what? You have to save it, right? Every single data professional faces this moment, and how you answer this question, well, it says a lot about your whole workflow.
And really, you've got two paths you can go down. On the left, you see the amateur way, maybe a quick screenshot, a messy copy-paste from your console. Yeah, it works in that one moment, but it's basically a dead end. But on the right, that's the pro move, a clean, structured file. The difference here is just, it's huge. It's about making your work last, for your teammates, for other programs, and maybe most importantly, for you, 6 months from now.
So that's the mission. We need to make that leap from a temporary output that just vanishes the second you close your window to persistent data that actually lives in a file. This is the bedrock of building any kind of data pipeline or any analysis you want to be able to reproduce later.
Now, the main tool Python gives us for this is the open function. Think of it as your gateway to the entire file system. But, it's a powerful tool, and with great power, well, you know the rest. It's actually really easy to mess this up. There's a right way to use it, and a pretty risky way too.
So let's talk about the single most important habit you need to build, like right now. It's using the with statement. I'm not kidding. This is absolutely non-negotiable for writing professional-grade code.
And the pattern is incredibly simple, which is great. You just use the with keyword to open your file. Then inside that indented block, you do whatever you need to do. Read from it, write to it, and that's it, you're done. The real magic of the with statement is that it guarantees, and I mean guarantees, that the file is properly and safely closed when you're finished. Even if your code crashes halfway through. No loose ends, it's a lifesaver.
And this right here is exactly why it's so critical. This is a warning straight from the official documentation. It says if you forget to close the file, your data might not even get fully written to the disk. Just let that sink in. Your program could finish, say everything's fine, but you're left with a corrupted or incomplete file. This is how those silent, impossible to debug data loss bugs happen.
All right, so writing a simple string like hello world is easy enough. But let's be real. When was the last time your data was that simple? As analysts, we're always working with these complex, nested things. Dictionaries inside of lists, lists inside of tuples, so what do we do then?
Let's take a look at this example. It's pretty typical for real-world data. We've got a tuple, and inside that is a name, and then a dictionary with more info. And then inside that dictionary is a list of projects. We need a way to save this entire structure and get it all back perfectly intact.
Now, the first thing you might think of is, hey, I'll just convert the whole thing to a string and write it to the file. But look at what you get. It's a complete mess. I mean, sure, the text is in the file, but how do you reliably get that back into a Python object? You'd have to write some brittle, custom parser. You've just created a massive headache for the next person who has to read this data, and that next person is probably going to be you.
This is where we bring in the elegant solution, the thing that's going to make your life so much easier, JSON. It stands for JavaScript Object Notation, and it has become the undisputed industry standard for exchanging structured data. The great news is Python speaks it fluently.
Okay, the first key concept we got to get our heads around is serialization. It sounds like a big, fancy word, right? But all it really means is the process of taking our complex Python object with all its lists and dictionaries and turning it into a standard, universally understood JSON string. That's it.
And you guessed it, the reverse process is called deserialization. This is how we take that JSON string that we saved in a file and perfectly rebuild the original Python object back in memory, all ready for you to use again. It completes the round trip.
And here is the absolute best part. You don't have to do any of this tricky stuff manually. Python comes with a built-in library, the JSON module, and it handles all the heavy lifting for you. It already knows exactly how to convert all the common Python data types back and forth. Now, this is a really interesting slide because it shows the transformation. On the left, a normal Python list. On the right, what you get after running JSON dumps. It looks really similar, but notice the subtle changes, like the quotes. This is now a universally understood JSON-formatted string. And what that means is you can send this file to a colleague who uses R or a web developer who uses JavaScript, and they can all read it perfectly, no problem.
So let's put all the pieces together. We've got the with statement for safe file handling, and we've got the JSON module for our structured data. This right here, this is a complete professional workflow that you can and absolutely should use every single day.
So it's basically a two-step process. First, you have your data in a regular Python object, like this dictionary. Then for step 2, you use that with statement to open a file for writing. And inside that block, you just call json.dump and you pass it your data and the file object. And notice we're also specifying encoding UTF-8. That's a critical best practice, don't forget it.
And now for the other half of the trip, getting the data back. When you or someone else needs to use it, you just do the reverse. You open that same file for reading, again using a with statement, and this time you call json.load. It reads the file, parses all that JSON, and gives you back a pristine Python object.
And here it is. This is the magic. This is the whole payoff. When we compare our original data object with the new one we just loaded from the file, the result is true. They are identical. We've done it. A perfect, lossless transfer of our complex, structured data from memory to disk and right back to memory again.
So let's just quickly recap the big takeaways here. Number 1, always use with open for file operations. It guarantees they get closed safely. 2, don't fall into the trap of converting complex objects to strings manually. Just don't do it. 3, use Python's built-in JSON module to properly serialize your structured data. And 4, don't forget to specify UTF-8 encoding. You know, by mastering this workflow, you're not just saving a file. You're creating reliable checkpoints for your long-running analyses, you're building reusable datasets for your team, and you're making your work compatible with countless other systems. The foundation is set, so the only real question left is, what are you going to build with it?